Hi, and welcome to Geeks for Geeks. Today, we would be discussing the problem named as the bit game. So, in this problem, there are two players that are playing the game. First one is player one, and the next one is player two. Simple enough. So, now we are also given an integer n. An integer n, if we consider the binary representation of that number, then we can remove any set bit. Now, what do you mean by set bit? Let's take an example of suppose 5. 5 is equal to 2 to the power 2 plus 1, that is 2 to the power 0. So we can say that if we have something like this, then this is 1. We don't have 2 to the power 1, so that is 0, and 2 to the power 2, which is 1. So we can say that the number of set bits are these two positions. Okay, so we can remove any of the set bit. So if we can remove any of the set bit, so at each point of time, any set bit is being removed, and player 1 and player 2 is playing the game. Okay, fair enough. So let me just evaluate the test cases. So we are given the input as 8, which means that 2 to the power 3. So if we have 0, 1, 2, and 3 itself, so this would be like this. So we can directly write this, but I'm just writing in the same manner so that you get the idea how binary representation are being written without having to get to the process. That is the mathematical one. Okay, how by intuition you can directly write it. Okay, fair enough. So the number of set bit is just one. So player one, as he always starts the game, he would just come and he would remove this. After that, no set bit is there. So player two is not able to make any move, and the person who is not able to make the move would lose. So if player two loses, that means player one would win. So we can say that yes, player one would win. So now the problem is pretty straightforward. Why? Because if you observe, the number of bits which are not set has no importance to us. Only the number of set bits are important. So now the solution can be straightforward. Like if we have 3 bits, okay, then player 1 would remove this bit, player 2 would remove this bit, and player 1 would remove this bit. So if the number of bit is 3, then player 1, player 2, player 1, and then player 1 is making the last move. So as of now, we can say that player 1 is winning. Okay, so let's take one more example. Okay, now let's say the number of set bits are 1, 2, 3, and 4. So here in this part, player 1 would make the move, player 2 would make this move, player 1 would make this move, player 2 would make this move, and the last move made is player 2. So player 2 would win the game. So now, if you just draw out some more test cases, like if you have some odd set bits and you have even set bits, you can see that when the number of set bits are odd, then player 1 would win, and the number of set bits when it is even, player 2 would win. Simple enough. Like the first one, player 1, player 2, player 1, player 2. Okay, like this. So we can say that if it is odd, the number of ones in the binary representation is odd, then player 1 would win, else player 2 would win. This is simple enough. So now the main problem boils down to the conclusion that we want the number of set bits. So now how can we find the number of set bits? To find the number of set bits, we can have something like this. So let's find the number of set bits in 7. So we can have something as 2 to the power 2 plus 2 plus 2 to the power 0, which is equal to 4 plus 2 plus 1. And this is equal to 7. So 0, 1, 2. And all of them is 1, 1, 1. Okay. So now what we can do is we can simply do a AND with 1, and we would know the last bit is set or not. So we know yes, last bit is set. Then we can do is we can have it right shift. Okay. Right shift would shift the number by 1, 1. Okay, now what is right shift? Just would give you some more insights to it. Suppose this is 1, 1, 1, and this is right shift by 1, which would make it everything go right by 1 place. If it is 2, then 2 place, 3, which is 2 place. So this would be 1, 0, 1. If 1, 0, 1 right shift by 1, it is 1, 0. And same goes for left shift. As left shift is not required, so we would just move forward with that. So now each time we can just do a AND with 1, and we can check if the last bit is set or not. Like we would just do a AND with 1. If the value is 1, the bit is set. If the value is 0, the bit is unset. See, like 1 0, and if we do AND with 1, the value would be 0. Here the 0. So 0 would be the value. So if it is 1, the bit is set, else bit is not set. And each point of time, we would just do a right shift of it. Fair enough? Now, let us move to the coding part, and it would give you better insights to it. So now what we can do is we want to store the number of set bits. So we can have int answer is equals to 0. And then we can simply have a while loop, and we would say while n is greater than 0. Okay. And then answer plus is equals to n and 1. If the value is 1, it would add 1. If the value is 0, it would add 0. Simple thing. Okay. And each point of time, n would be right shift by 1. Fair enough. This is how we are counting the number of set bits. And as we have said, if answer modulo 2 is equals to 1, if it is an odd number, then we would return yes, player 1 is the winner. Else we would return player 2 is the winner. Okay. So let us just try to submit this and see. Yes, we are getting a solved AC count. So now I saw many of the submissions, and I saw that many people were having a issue with the built-in pop count. Okay, so in C++, you can directly use the built-in pop count to count the number of set bits in a number. Okay, but it is still giving a wrong answer verdict. Okay, so what we can do is we can simply have built in then pop count, and here is the small thing that you need to do. We need to use LL at this point of time because the given value is long. And after doing this, we would have this and we would just comment out this. Now let us try to compile and run first to see if our syntax is correct. Yes, let us try to submit this and see. And yes, it is giving an easy verdict. Now, if you were here till this point of the solution, consider liking the video and commenting on the video for better reach of this video. Thank you and have a nice day.